Hey guys, welcome to the tutorial on graphs, and in this I will be discussing about the another search traversal, that is BFS, which is Best First Search. So now let's look at how BFS works, and after that I will show you how to code it. So if we have this graph given in the form of vertices and edges, and this graph is represented in unordered map, which I will show you while doing the code. Now if we have the start index as 0, then the output for the BFS will be 0, 1, 2, 3, 4, 5, 6, 7 and 8. So how this output came, I will show you with the step by step, but before that just keep in mind that as the name suggests, Best First Search, it will go level by level. So this is also known as level order traversal, because it will complete the search in this level, then only it will go on to the next level, then it will go on to the next level, and so on. So it will follow the level order traversal. So now how this output is generated, let's look at it. And there may be more than one possible output for this, like 0, 3, 2, 1, 4, 5, 6, 7, 8. This is also a valid possible output for BFS. Now as DFS internally uses stack, BFS uses queue data structure, which is first in first out. Okay, so we have to maintain one queue which will keep track of the node which we have to visit, and one node may not visit more than one time, so we will maintain one array named visited, which will keep track which node is already visited and which is yet to be visited. So let me write down the nodes and initialize the visited array with all false. That means no node is visited till now. Okay, so let's now start with our iteration. We are starting with node 0, so first we will enter node 0 onto the queue, and after that the process will begin. So while we will go up to while not queue dot empty, that means whenever there is at least one element onto the queue, we will repeat this process. So first we will take one element from the queue from the front and print it out, and put all the neighbor elements of that node onto the queue, like 1, 2 and 3. Okay, and make visited of 0 as 2. We have to make visited of that node as 2 which we are taking out of the queue. Okay, after that we are taking out next node from the queue, that is 1, and print it out, and make visited of 1 as 2, and put all the elements of the neighbor into the queue which is unvisited. Okay, just keep in mind we have to put that elements only which are unvisited. So unvisited node for 1 is 4, so we will put 4 onto the queue and repeat iterate our process. So next element from the queue which we have to pop out is 2, and we will print 2, and make visited of 2 as 2, and put all the neighbors onto the queue which are not visited, which is 5 and 6. After that, take next element from the queue which is 3, print it onto the screen, and make visited of 3 as 2, and put all the neighbors of 3 onto the queue which is 7. After that, take one more element from the queue which is 4, and 4 as 4 is the leaf node, there is no neighbor which we have to put into the queue, and make visited of 4 as 2, so that it will not come again. After that, take one more element from the queue which is 5, put all the neighbors of 5 onto the queue, but there is no neighbor which is left unvisited, so we will make visited of 5 as 2. After that, take 6 from the queue, make visited of 6 to be 2, and print it into the screen, and put all the neighboring element into the queue which are left unvisited, so put 8 into the queue, and repeat this process. Next time we will pop 7 and 8 and make visited of both as 2. So as we can see, the visited array for all the nodes became 2 at the end. So we don't have any node left which is unvisited, and we are with our sequence of breadth first search traversal, which will be shown in this traversal method. Okay, so we have to keep this in mind that more than one BFS traversal is possible for a particular graph. Also, BFS uses internally queue data structure, okay, and unvisited array which is used to keep track of it. So now look at the code of this, that how to code this. Okay, as you can see, I have represented the graph in the form of the unordered map. Okay, the graph is 0 1 2 3 4 5 6 7 and 8, which I explained with the help of the example with the starting node as our 0. Okay, after that, these are the values which we have inputted into unmodeled map, which is our graph, and we have taken an extra array which is visited, which is used to keep track of the node which are visited or not visited. Initially it is initialized with all the false value which I have shown you. Okay, then we call the Bfs function, Bft function, with arguments as graph, the starting node which is in this case is 0, and the visited array. So now look at the Bft method. Okay, so in this we have passed the unordered map, the starting and the visited array. We have taken one queue. As I explained, it uses queue in data structure internally, which is used to keep track of the nodes level by level. We inserted starting node onto the queue, which is 0, and while not queue is empty, that means whenever there is at least one element onto the queue, what we're gonna do is we're gonna take the front element from the queue, that is 0, make visited of that current element as true, and we will pop this element from the queue as I explained it with the help of the example. And for all neighbors of that particular node, that is 1 2 and 3, if it is not visited, this is a condition for checking whether it is visited or not. If that node is not visited, we will insert that node onto the queue. This is our queue, so we'll insert that node into our queue. Likewise, after that, inserting all the neighbors into the queue which are not visited, we print our output. So on, in the next iteration, what we have to pop the next element from the queue, and so on. So effectively our output will be like this only. Okay, so this is the breadth first search traversal method, which is very popular in graph. So now let's execute this code and see what the output looks like. Okay, so before executing, first compile our code. So as you can see, it is compiled successfully, and when I run it, it will print the same output as we are expecting. Okay, so this is the session on BFS. Hope you get everything which I taught. If there is anything which is left unclear, just drop down a comment and I will happy to help you. Thank you.